algebraic manipulation. Okay, multiplying out two brackets then. So whichever method you choose to use. We've got 2x times 3x giving us our 6x squared. We've got minus 6 times positive 4 to give us minus 24. Minus 6 times the 3x giving us minus 18x. And 2x plus the 4, 2x multiplied by the 4 to give us 8x. So just tidying up then, collecting our like terms. So minus 18x plus our 8x giving us minus 10x. So 6x squared minus 10x minus 24. Second one then, multiplying out our bracket. We've got 3x times the x squared giving us 3x cubed. 3x times the 2x which gives us 6x squared. And 3x times minus 6 giving us minus 18x. The second bracket then we've got minus 5, being careful that we take the minus with the 5, so minus 5 times x squared giving us minus 5x squared, and minus 5 times minus 2x giving us plus 10x, okay, being careful with that plus. Again, collecting your like terms together, we've got 6x squared and a minus 5x squared giving us a positive 1x squared, and we've got minus 18x and a positive 10x, so minus 18x plus the 10x giving us minus 8x. So 3x cubed plus x squared minus 8x. Okay, next example then, slightly longer one. This time we've defined the value of constants k, a, b and c. Okay, so we're given the identity and we're going to work out the value of these constants. So the first step then is to multiply out these two brackets. So 2x times x squared giving us 2x cubed. We've got 2x times 3x giving us 6x squared, and 2x times minus 5 which is minus 10x. And then k times x squared is kx squared, k times the 3x giving us 3kx, and k times minus 5 giving us minus 5k. And just to do a wee bit of tidying up on the left hand side here, just rearranging and bringing our terms together. So we have a 6x squared and a kx squared. We'll just write those side by side. And we've got a minus 10x and a plus 3kx, again bringing them side by side, and the constant minus 5k. Now, in order to work out the value of these constants then, we're going to equate the coefficients. Okay, so there's our 2x cubed term on the left, and we have a kx cubed term on the right. So we're going to equate the 2x cubed and the kx cubed. And we can say there that 2 must equal k. So we've got our first value, k is 2. Doing exactly the same thing then with the x squared terms. So we've got a 6x squared plus a kx squared on the left. We've got an ax squared on the right. So taking the coefficients out of those, we've got a 6 plus k has to equal this a. But we already know the value of k from above is 2. So 6 plus 2 then is a, giving us a value of a to be 8. Doing the same thing then with our x term. So we've got 3kx minus 10x, and we've got a bx. So taking the coefficients, 3k minus 10 has to equal this b. So 3k minus 10 is b. We've got k again being 2, so 3k is 6, minus the 10 gives us a value of b to be minus 4. Taking the constants then, I've got a minus 5k, and I've got the c on the right hand side. Again, using the value of k, we've got 2, so minus 5 times the 2 gives us minus 10, giving us the value of c. So we've got k, a, b and c, which is what the question asked for. Algebraic fractions. Okay, algebraic fractions, we use the same rules as we would use for normal numeric fractions. So when we're adding two fractions, we need a common denominator. So in this case, we've got a 2 and we've got an x plus 3, and the lowest common denominator will be 2 upon x plus 3. And it's the lowest term that both the 2 and the x plus 3 will divide into. So 2 upon x plus 3 being our denominator, we must now create equivalent fractions with that new denominator. So I've multiplied the 2 by x plus 3, which means I have to multiply the numerator also by that x plus 3. And in the second part, we have multiplied the x plus 3 by 2 to get our common denominator, meaning I also have to multiply the 2 on the numerator by 2 as well. So multiplying out the brackets then, I get an x plus 3 plus this 4, and I can combine the two denominators together. Tidying up on the top gives me x plus 7, so my final answer then being x plus 7 over 2 upon x plus 3. Always do a final check at that stage that there's nothing else that can be simplified in your answer. Part B is a subtraction question. We've got denominators of x plus 3 all squared and x plus 3. So the lowest common denominator will be the x plus 3 all squared, as both these terms will divide into that. So we don't need to change anything on the first fraction. The second fraction, to get the x plus 3 all squared, means we have to multiply the denominator here by x plus 3, giving us 2 upon x plus 3 on the numerator to give our equivalent fraction. Please note at this stage we can't say that we've squared the denominator, meaning I square the numerator and get a 4. That is incorrect. I multiplied it by x plus 3, I have to multiply the numerator also by x plus 3. So multiplying that out, I get a 1 minus 2x minus 6. Okay, being careful to note that as a minus sign or subtraction sign, so it's minus 2 times the 3 giving us minus 6, and again combining the denominators here. Then all that's left to be done is just tidy this numerator up. We've got a 1 minus the 6 to give us minus 5, giving us in total minus 5 minus 2x over the x plus 3 all squared, and again checking that nothing else can be simplified in that answer. Right, part C, we need to be careful of part C as we've got two operations going on, and we must remember our laws of BIDMAS. Okay, the laws of BIDMAS say we must do brackets first, so the bracket will come before the division. So taking the terms in the bracket, we've got 2 over x plus 4 minus the 3x. Subtraction question again, meaning we need a common denominator. And in this case, the lowest common denominator will be x upon x plus 4. So multiplying the 2 by the x to give us an equivalent fraction. And the second fraction here needs to be multiplied by x plus 4 to keep it as an equivalent fraction. So multiplying out the bracket here, we've got minus 3x and minus 12. Combining those and combining the denominator gives us 2x minus 3x minus 12. Tidying up then, 2x minus 3x gives us minus x minus the 12 all over x upon x plus 4. So that's the bracket part of the question done. We now need to go back and look at the division part. So taking our answer from the brackets here, dividing by the x over x squared minus 16, remembering that when we divide with fractions we we turn the second fraction upside down and we turn this into a multiplication sign. So the first fraction isn't going to change, and the second fraction then we turn upside down and we multiply it. But the denominator here was an x squared minus 16, which you should have spotted as a difference of 2 squares, meaning it can be factorised, and it will factorise to give us x plus 4 upon x minus 4. So we can see here that we can cancel the x plus 4 on the denominator of the first fraction with the x plus 4 on the numerator of the second fraction, which leaves us with minus x minus 12 multiplied by x minus 4, and on the denominator the x times this x giving us x squared. And it is tidier not to multiply out the numerator here, but leave it in its factorised form. Okay, part D then. We have got 1 over 2 upon x plus 4 minus 3x over x plus 4 all squared plus our half. So again, two different operations, but according to the rules of BIDMAS, we can do our subtraction and addition at the same time. So with both operations, we need a common denominator. So looking at our three denominators, the lowest common denominator is going to have to be 2 upon x plus 4 all squared. So to make our first fraction equivalent, we need to multiply the numerator by x plus 4. For our second fraction, we're going to have to multiply our numerator by 2. And our third fraction, we need to multiply the numerator by x plus 4 all squared. Multiplying out our brackets then on the numerators, we've got x plus 4 from the first. We've got minus 6x from the second, and we've just got x plus 4 all squared from the third. Now, we need to multiply this out, remembering that x plus 4 all squared is the same as x plus 4 upon x plus 4. So multiplying those out then, we've got x squared plus 4x plus another 4x plus the 16, giving us x squared plus 8x plus 16. So collecting your terms and tidying up the numerator, we've got x squared minus 6x plus 8x plus this other x at the start gives us positive 3x, and 4 plus the 16 giving us the 20. So final answer then, x squared plus 3x plus 20 all over the 2 upon x plus 4 all squared. And again, keep this in its factorised form. Don't multiply out that squared bracket. And part E, always look at a fraction and see if anything can be factorised. Factorising means we can cancel terms out and it makes the calculation much easier. So it's a multiplication question, so we don't need to worry about common denominators. So let's look, we've got a quadratic on the numerator of our first fraction, and we can factorise that to m minus 7 upon m minus 7. On the denominator of that first fraction, we have another quadratic, and that can be factorised to give m minus 7 upon m minus 3. And then in the second fraction, there's nothing there that we can factorise. So looking to see if we can do any cancelling, I've got an m minus 7 here, which can cancel with an m minus 7 on the numerator of the first. I've also got an m minus 7 on the numerator with an m minus 7 on the denominator, so these two can cancel and these two can cancel, and that just leaves me with a 1 on the numerator here times by the 8m, and an m minus 3 multiplied a 1 that's left in the denominator of the second fraction, giving me 8m over m minus 3 as my answer.